today I will talk about TinyGo and how I use it actually for my hen house. So as he said, my name is Donia and my last name is Chaiehloudj, but you don't have to remind it. You can just remind Donia CLD, which is my handle. And I'm a backend developer at Powder, which is a startup building social app for gamers and content creators. So today I will cover what is my ideal hen house and how I use TinyGo for it. If you participated yesterday at the hack session, the first part will be reminders. Then I will do a little demo about how it looks like, and I will wrap up with the things that I learned about TinyGo and what are my next steps in this project. So let me introduce you first my hens. The one at the front is Bleuette, and the one at the back is Francine. And you can see their house. It is, for the moment, partially automated. There is an opening and closing door system, but I actually bought it. And I wanted to contribute with my skills to upgrade my hen house. So I decided for this first step to monitor the temperature and the humidity and visualize these metrics. This is what I'm going to talk about today. My final goal was to have nice dashboards, and Grafana is pretty nice for that. So you can see that here there is temperature and humidity graphs, but we'll see that later. Let's dive into TinyGo. What is TinyGo? TinyGo is a compiler for the Go programming language, but for smaller kinds of systems. And you can wonder, what are small kind of systems? So it can be microcontrollers. Currently, TinyGo supports 85 boards. It can be also to build WebAssembly. There are some companies that are using it currently. And another application could be just, I want to build a tiny command line interface, for example. There is a difference between TinyGo and Go compiler. This is the layer of optimization that it is using with LLVM, which is just a collection of modular and reusable compilers and libraries. So this is the main difference here, and it made the difference of the size of the binary pretty huge. In my case, I was using actually a microcontroller, by the way. That's why I'm using TinyGo. So let's see a little application with a basic hello world. If you build with Go a hello world, just a println hello world, the size of the binary will be 1.8 megabytes. And if you build it with TinyGo, it's going to be 107 kilobytes. So you can see that Go binaries are 20% larger than TinyGo binaries, which make a huge difference for the embedded world. We've seen some theory here about TinyGo. But what are the commands that we can use? The main one is called flash, TinyGo flash. And you precise your target because the architecture of your board is very important here. TinyGo flash compiles the program on your computer and then writes it on the chip memory and finally runs it. Each time you're going to run and reset your board, the program is going to start over. And on my board, actually, the Arduino Nano 33, when I'm flashing, I have my built-in LED that is blinking while writing, so I know that I'm actually flashing my board. And when you're developing, most of the time you need to debug. And I use our old friend println and the standard output most of the time. And to do that, I plug my Arduino on my computer. It's plugged to a serial port, and then with a Go program, I can actually read from the serial port the standard output from my chip and print it on my console, on my computer, so I can see what's going on. Otherwise, it's like a black box. But you can use also the TinyGo debugging tool. Here's an example again when I read from the serial port. So this is just a hello world again, greeting you all, the GopherCon Europe. And when I run it with Go, it's basic. You have just your logs, And with your TinyGo, when I flash it, I plug it on my computer, and I read from the serial port with a Go program here, precising my serial port, I can see that I have my logs, but beginning at 0 Unix time. That's because on my board, I don't have sync time, synchronization time. So I'm just beginning to 0 each time I'm resetting my board. So don't count on the time here. You have the basic now of TinyGo. So you see, it's not very complicated for the moment, I hope. Let's back to my project. Here is the hardware that I used. 2 components here. My Arduino Nano 33 IoT, which is important here because I can connect to Wi-Fi. And the DHT22. It's the basic on the electronical market sensor for temperature and humidity. And they are plugged together thanks to 3 wires. The first one is the data, so I can ask for data, send data. The other one is the power supply, and the last one is the ground. You have an idea of what it looks like in picture. It's pretty like the schema. Here is the full setup. So on one side, there is the hen house. In there, I have my Arduino and my DHT that are plugged together. I have a program running on it, and it's built with TinyGo. On the other side, I have at home my computer. I have a Kubernetes cluster deployed with a web server that can receive HTTP requests with the sensor values. And I also have a monitoring layer, so I can actually build dashboards with Prometheus and Grafana. Actually, when I brought my Arduino in my hen house, it was not working anymore. Can you guess why? It was so far. My hen house is at the end of the garden, actually, so it was not receiving any signal anymore. I had to buy a new router. So I added a router access point. My Arduino is actually connected to it, and I have another router at home, like the basic one with Wi-Fi. The 2 routers are communicating through a power line. So currently, I have a long cable along the garden, which is not very easy and, practical. In production environment, it looks like this. Looks like a disaster? No, it's working, actually. So the first picture is the router that you can see here. I bought it. And it's under the hen house. It's plugged, and there is also the power supply of the Arduino here. In the hen house, you can see Francine. But you can also see the Arduino and the DHT that is protected in the plastic. Not the DHT, only the Arduino. OK, so we've seen the hardware part now. Let's see the software. So I'm running a program on my Arduino. I need for that some packages from TinyGo. The standard libraries from TinyGo are kind of the same of Go, but slightly different, like FMT and time. And machine is a specific package that lets know Go how to talk to the board. I also use the TinyGo drivers that are very useful here, because it's a layer it's an interface layer that enables me to just call read.measure, dht.measure, for example, for my DHT, and not manipulating bytes. Otherwise, I would have to set instruction 0x01 to ask for a measure. I don't want to do that. Like, I'm a golfer. I want to have interfaces. That's the same for Wi-Fi Nina, and also for Net. I'm not going to show you the full code here, but you're welcome to see the GitHub. It's only the pseudocode, so you have a glimpse of what it looks like. So first, I'm setting up my device, saying what are the pins that I'm using, connecting to the Wi-Fi, for example, setting up the Wi-Fi details, and then connecting to the Wi-Fi. And finally, each 10 seconds, I'm asking the DHT for a measure, and it's returning the temperature, the humidity, and an error, maybe. And if there is an error, I'm just printing it. And if it's succeeded, I'm just sending these measures through HTTP to my web server on my computer at home. I will not go into details about the web server. We probably all know how to write it. If you are a newbie, go just check the code. The only thing here that is important, it's about Prometheus and the metrics. So there is a library in Go in Prometheus that enables you to set up different type of data. Here I'm using the gauge, so I can set up my two metrics, the temperature in Celsius and the humidity in %. And then it can be scraped. This is the full infrastructure, so you just have an idea what it looks like. It's pretty simple. When you deploy the cluster, I have my Arduino that is talking to my cluster, and I had to actually deploy an Nginx just to expose my IP of the web server outside of my cluster, so they can actually communicate together. I instrumented it with a service monitor on Prometheus, so I can scrape the app metrics, the humidity and the temperature, and then I'm sending these values to Prometheus, to Grafana, and at the end, I have my dashboards. This is demo time. I hope you're all praying for me, the God demo right now. OK, so here, I'm going to first check everything is blocked. I'm going to check that my Wi-Fi is connected to the right Wi-Fi. No. Yes. No. Yes. OK, so this is my router. I'm currently connecting to my router. And my Arduino is, when connecting to Wi-Fi, it's connecting to this router. Let's see how long it's going to take to connect to the router. It's actually pretty green, so I hope it's going to work. So let's first flash the Arduino. So to flash it, I'm going to use the TinyGo flash command. Can you see over there the first line? Yes? Great. No? Can you see? Sorry. Can you see the line now? Great. OK, so here I'm flashing my Arduino with the command TinyGo flash, as I said. I'm putting the board, the type of the board. Here it's an Arduino Nano 33, and the name of my program. Let's pray again. Sometimes it fails, so we're going to see. And check at the meantime, it's connected. So what is interesting here is that the total size of my device is 256 kilobytes. I cannot write a hello world built in Go on it. That's pretty crazy. And now it's succeeded, we are done. We're going to read what happened on my Arduino. And to do this, I will use the read serial port program that is actually connecting to the serial port and reading from it to print the started output. OK, so this is not the right port. So I'm just going to replace it. So to find your serial port, you can check. So I'm on a Mac, so it's /dev/cu. But on a Linux, for example, it's going to be TTY. So just know. So what's going on here? It's working. It's pretty hot on the stage, isn't it? So what you are seeing here, it's the temperature that are actually taken from the DHT that we have here. I'm going to show you this right now. OK. Have the board. So here we have measuring the temperature. And what we want to see now, that we have seen that the Arduino is properly logging the temperature and the humidity, I'm going to check my web server, just, to check that I have everything going on. So currently, I have my cluster that is already deployed. It was not really interesting for the demo, isn't it? So we can see here that we have, OK, I'm in UTC on my cluster. So that's the proper time. But we can see that it's sending the measure every 10 seconds on my web server, and I have the humidity and temperature values. Now we have seen this, we can see on Grafana what it looks like. So every 5 seconds, I have my values here, and we can see different type of values. So we have first the minimum value in the period of time that is displayed here. We have the average value, the maximum, the last one, very basic, I just need basic values for the moment. And I have my graph, so I can see if I'm up and down. I put threshold just to know if my hands are cold or not. If I need to go check, or if they're too hot, I need to bring more water. And at the bottom, it's just table with values. It's easy for debugging because I can see the list of values instead of just having graphs, OK, what I'm going to do right now is to make the temperature and the humidity increase. And for that, I'm going to blow on the DHT, and I will show you the dashboards at the same time and see what happens, how hot we're going to be. Oh, so here, sorry for the noise. I don't know if it's very noisy. OK, let's see now what's going on. So just I currently have on Prometheus a sampling of 30 seconds. So it can take some time just to have the last values. And it's something that I should change, definitely, because on my DHT, I'm sending every 10 seconds. So I'm just missing some values for the moment. OK, not too bad. 53.6% here. And not much here, only 1 degree. We can do better. My husband actually taught me how to make the DHT increase. He told me you should blow very slowly and just like slightly, and it's going to be very hot, you're going to see. And actually, when I tested it, it went to 90% of humidity, and I put 3 more degrees. I don't know if I'm going to succeed here, but it's just, you can see it. Not sure. Maybe. Let's wait a bit. Oh, 91.5 here. We're going to see it. Yay! So now we have seen all this stuff. It's time to wrap up. I hope you enjoyed this demo. And I wanted to just wrap up with the things that I learned, and I want you to remember of this presentation. It's a TinyGo cheat sheet. Please take a picture of it. So TinyGo is a Go compiler for small places. And small places means not a large memory. You can use Flash to actually flash your board and write on it a program. When I began to code with TinyGo, I used a lot the drivers example in the source code of TinyGo. And it's a treasure chest. There is a lot of electronical components and example, but it's also full of bugs. I'm sorry, Ron. I'm sorry, Daniel. But it lets me to contribute for the first time to TinyGo. And I fixed the drivers from the DHT. I was very happy for this first contribution to TinyGo. You're very proud when you did a first contribution to a repository. I do not have any hardware strong recommendations. I know that the Arduino Uno is a very basic one. And there is also the TinyGo Playground that is simulating boards, so you can try it. And it's built with TinyGo and WebAssembly, which is pretty fun. And now, as Gopher, you can enter the IoT world very easily. with your current skills, and probably your IDE also, because if you have VS Code or Golang, there is a plugin for it. As you have seen, this project is pretty experimental for the moment. But I have some next steps. I'd like to use async protocol, because I don't really need HTTP. I began with it because I knew it, but MQTT would be great, I think. I want to get rid of this router access point. I really need a long-range Wi-Fi board, so I just have no more cables in the garden. And I brought all my stuff here, but I would love to have like my app deployed in the cloud or exposed somewhere so I can check from anywhere in my dashboards. And long story but short story, when I submitted this talk, we had 3 hands. And the fox went there. But there is a long story behind. I can tell you after that. But I would like to add a fox detection system. I have no idea how, but if you have any suggestion, I will take it. Thank you a lot to the TinyGo community, to Run Events and Daniel Esteban for their help and their support. Also to my friends and to my partner, because it's not a lonely project. We have been working all together for this. You can find all the source code on my GitHub. I'm also on Twitter, LinkedIn, and social medias as Donia CLD. Thank you a lot.